So bacteria have developed a form of communication where they can coordinate group behaviors and do things that are beneficial to the population as a whole. So these behaviors would include things such as population migration or also niche protection, defending their territory. This communication happens through the synthesis and release of these tiny little signaling molecules, almost as if the bacteria are making their own scents that other organisms in the environment can smell. So the concentration of these signaling molecules are a direct reflection of the number of bacteria that are in the population. So when there's a low number of bacteria, the signal will simply dissipate into the environment. However, when the number of bacteria increases, so does this signal, and bacteria can sense that. Okay? So the signal increases and bacteria can sense that. It's like walking into a locker room. When there's one player sitting there, they may be pretty stinky, but you can probably escape the smell by walking to the other side of the room. However, when you have an entire team sitting in there, there's nowhere you can go to escape that smell. Within the bacterial population, the signaling compound actually passes a certain threshold. And when this happens, this indicates to the bacteria that it's time to make a behavioral shift. The bad news is that harmful bacteria can actually use this form of communication to coordinate infections. For example, the bacteria that causes cholera is passed through contaminated drinking water. Once this bacteria reaches our intestine, it'll latch on to the intestinal wall and release toxins that will cause the severe infection associated with cholera, resulting in massive release of water, leading to dehydration and death. This is happening early on, therefore there is usually a low number of bacteria at this point. Over time, as the number of bacteria increases, so does the signal that they are producing. Therefore, once the signal passes a certain threshold, all the bacteria that are latched onto your intestinal wall will stop making the toxin and simply let go. This ensures that the bacteria can reach a high enough population before being flushed out of the body, making it more likely for them to be passed on to a new host and cause the whole thing over again. The good news is that scientists can now exploit this type of communication to fight infections. For example, an E. coli that actually lives in our gut normally was engineered to create the same signal that is created by the bacteria that caused cholera. Therefore, these E. coli actually had the same scent as the cholera bacteria. And what this did was actually confuse the cholera bacteria to think that they had more numbers than they actually did, leading them to prematurely let go of the intestinal wall and leave the body. This caused a less severe infection, and it ended much more rapidly. Doing this and being able to exploit communication specific to different bacteria is actually a much more targeted approach and would be invaluable when dealing with bacteria that are actually resistant to multiple forms of antibiotics. Thank you.